in this video, we will be looking at volumetric analysis, right? And some terms that you will have to get familiar with is concentration, molarity, mass concentration, standard solution. So volumetric analysis is simply a quantitative analytical method. That means we will be using it when we want to determine the exact amount of substance that is present, or for instance, you want to know what proportion of a solute is present in a solvent. So quantitative, you want to know the exact amount of substance that is present in a sample. And it will involve a lot of calculations. We will often prepare solutions. So, all right, let's go. We're going to start off with concentration. Once you are doing volumetric analysis, we will be dealing with concentration. All right, so if you're at home, so let's start. And you're making tea or drinks, you will, in your container, you will pour water and you will add some solute. Right? So basically, you are making a solution. So remember now, for this solution, it has two parts. The liquid component, which we call the solvent. So you will have the liquid component called the solvent, and the solid particles, which is the solute. Good? So in a solution, right, so this would be a solution. So in your solution, you will have solute and you will have solvent. Now, if you make the drinks, right, or the tea, and you say it is sweet, the term that we are going to use now, if you say it's sweet, it means you have what? A lot of solute particles compared to the solvent particles. So if you say a solution is sweet, if you say your drinks is sweet, right, it will have a lot of solute particles compared to the solvent. But we are not going to use, in chemistry, we use the term concentrated. So if your drinks or tea or whatever you're drinking, if it tastes sweet, it has the number of solute particles to the solvent is high. So in chemistry, we don't have a solution that is sweet, we have a solution that is concentrated. And if, likewise, if you say it tastes fresh, it's because the solute particles compared to the solvent is very low. So you only have a few solvent particles. Chemistry, I'm not going to say fresh, we use the term diluted. So when you make a solution, it can be concentrated, it can be diluted. Now, next one is the amount of, if you keep on adding the solute to the solvent, it will reach a point where no more of the solvent will dissolve, right? So the solvent, it will settle, right? You will actually see it, right? This solution, right? So if you add enough solute, right, that some of it will not dissolve, that solution is saturated. Good? Right, but these two are what we are focusing on, right? Where the particles, all of them will actually dissolve. Good? So when you make drinks or tea or whatever, that's basically a solution. You will dissolve a solute in your solvent, which is water. Now, the term concentration. If I ask what is the concentration, or if I ask you now, what is the ratio? So you will place some solute, or let's say sugar, be practical, put some sugar in water or salt in the water. And I ask you, what is the ratio of the salt particles to the water? So you have a container, right? You pour some water in it. You haven't measured how much water, you just throw some water in it. And then you add some salt to it as well. And I ask you, what is the ratio of the salt particles to the water? So basically I'm asking you, what is the ratio of your solute particles compared to the solvent? You did not do any measurement, so you cannot tell me. So the concentration, that is what concentration is. It is letting you know basically the amount of solute particles compared to the solvent particles. So in order to find the concentration, you must know the solute, right? You must know the exact amount of solute that you added to the solvent. So you must know the solute and the solvent in order for you to be able to calculate concentration. So I want to remove the solvent water from here. So if you want to find the concentration, this is concentration for short. So it's basically the solute divided by the solvent. So obviously, you would need to know the exact mass of the solute and the exact volume of the solvent. So for example, if you added 5 grams of salt, so you would know that you added, so you weighed 5 grams of salt and you poured it in some water. What volume of water did you use? If you don't know the volume of water, then you cannot calculate the concentration. Likewise, if you just added some salt to 100 cm³ of water, then again you cannot calculate the concentration if you don't know the mass of the salt you added. So if you know one of the two, you cannot calculate it. You would have to know both of them. So if you put 5 grams in 100 cm³ of water, that is when you would be able to calculate concentration. So concentration is the ratio of your solute to solvent. So that's how you will need to calculate it. But this will not be the formula that we will be using. The solute, so when we speak of concentration, the solute, we will use two forms. So the solute will be expressed in 2 ways. Our solute can be expressed in terms of mass or in terms of moles. So for concentration, you will not see solute divided by solvent. Our solute will be expressed in 2 ways, in terms of mass or in terms of moles. And our solvent, that is volume, and the unit for the volume is liter or dm cube. So it's liter or dm cube. So if we're using mass as our solute, we are going to find mass concentration. If we are using moles as our solute, so we like to use the term molarity. So when we're using the moles, we will find the molar concentration. We'll be finding molar concentration. The next term for molar concentration is molarity. So if you are finding if the question asks you what is the molarity of the solution, then you are asked to find the molar concentration. So again, our solute can be expressed in two ways, in terms of mass or in terms of moles. If you are expressing it in terms of mass, we are going to find mass concentration. So if you are finding mass concentration, you are not using moles. If you are asked to find molar concentration, you are not going to use the mass. And of course, we will be dividing. So mass concentration means that the solute is in terms of mass. And remember, concentration is solute over solvent. The solute in this case is mass, and the solvent, of course, is a volume because it's liquid. And the unit for the volume is liter or dm cube. We'll be using dm cube. The value of liter and dm cube, they are the same. So 1 liter is also 1 dm cube. So if we are finding molar concentration, that means our solute would be in terms of moles. So it would be mole over volume, and the unit for our volume is dm cube. And this would also be mass over volume, and the unit is also dm cube. So back to this formula, concentration is just the amount of solute present in the amount of solvent that you have. But the solute will be in two forms, mass or moles. If you are asked to find mass concentration, you will need to find the mass of the substance and divide it by the volume. The volume, it must be in dm cube. If you are asked to find the molarity of the solution or the molar concentration, you will need to find the moles and put it over the volume of the solution. So this is where we are now. Mass concentration is equal to mole over volume is equal to mass over volume, and molar concentration, that is equal to mole over volume. So let's work some examples. Alright, for example, 5 grams of sodium chloride was dissolved in 150 cm³ of water. what is the mass concentration of this solution. So here, the question, it gave you the mass of your solute, which is sodium chloride, and it gave you the volume of your solvent, which is water, and it asks you to find the mass concentration. Remember that mass concentration is mass over volume, and the volume must be in dm³, and the mass in gram. So let's go. So mass concentration is equal to mass over volume. The volume must be in dm³. To convert from cm³ to dm³, you would divide by 1,000. So to get the 150 in cm³ to dm³, you would divide by 1,000, and that would give you 0.15 dm³. So we would say no. The mass is 5 grams, and the volume is 0.15 dm³. So 5 divided by 0.15, 33.3. 33.3 grams per dm³. So if you are provided with the mass and the volume, it's a straightforward calculation. Just divide the mass by the volume, but ensure that you convert the volume to dm³. And that's it. Let's try one now with molar concentration. So here we go. A 200 cm³ sodium hydroxide solution contains 0.25 moles of sodium hydroxide. Determine the molar concentration of this solution. So we know that molar concentration is equal to mole over volume. But the volume must be in dm³, so let's just sort out the volume. So 200 divided by 1,000, that is equal to 0.2 dm³. So mole is 0.25 divided by 0.2. 0.25 moles divided by 0.2 dm³. 1.25 moles per dm³. So the answer is 1.25 moles per dm cube. Notice the dm cube here, it says it has -3, but the one here it's just dm3. The -3 here is signifying that you divided the mole by the volume, which is dm cube. So you could write moles slash dm cube. So if I put moles slash dm cube, the minus sign is gone. So the minus sign is basically is like the slash here. It is telling you that the mole is the numerator and the dm cube is the denominator. So if you put moles slash dm cube, do not put the minus sign. And when you are writing the volume, do not put dm cube, do not put dm minus 3. The unit for volume is dm cube, not dm minus 3. Right, so you got the volume in same cube, you convert it to dm cube by dividing by 1000. And then you just simply put the mole over that volume. So mass concentration is just mass over the volume in dm cube. So the unit for our mass concentration is grams per dm cube, and the unit for molar concentration is moles per dm cube. Alright, so we're going to work some more. These two are pretty straightforward. We're going to try one now where we are given the molar concentration. So in the third example, Alright, so in this question, all you are given is the molar concentration because it's about the molarity. And remember, molarity is the same as molar concentration. The amount of moles in a specific amount of volume. So when they tell about molarity, it is telling you about the concentration in moles per dm cube. So the molarity of a sodium hydroxide solution is 0.85 moles per dm cube. What mass of sodium hydroxide is present in this solution? Even though you got only one number here, it's actually two things. Look at the units. It says moles per dm cube. But it is telling you that in 1 dm cube of solution, you have 0.85 moles. So 0.85 moles per dm cube, it is saying that in 1 dm cube, so you have a container, right? You pour 1 dm cube of water inside of it, and then inside of the 1 dm cube, you have 0.85 moles present. So this is what the question is telling you. You have 0.85 moles in 1 dm cube of water. What it wants to know, however, is the mass of sodium hydroxide present. So all you're doing, it gave you the amount of substance of sodium hydroxide in terms of moles, but it wants it in terms of mass. And we already know how to do that calculation, how to convert from mass to moles. From moles to mass. If we remember for a mole concept, mass is equal to moles times molar mass. Sodium hydroxide is NaOH. We have one atom of sodium, that is, and the mass of sodium is 23. We have one atom of oxygen, mass of that is 16, and we have one atom of hydrogen, which is, and the mass of hydrogen is 1. So that's 23 plus 16 plus 1. And remember, the unit for molar mass is gram per mole. And the question, it told us that we have 0.85 moles. So it is 0.85 moles times 40 grams per mole. Good. And so we would get 0.85 times 40, and that is 34. So moles will cancel moles, you are left with gram. So 34 grams. Next question now, I'm going to give you the mass concentration. Alright. So this one now, it says the mass concentration of a sodium chloride solution is 2.25 grams per dm cube. What is the molar concentration? As usual, what is the question asking us to find? Molar concentration. And we know that molar concentration is mole over volume. So the question, it did not give us moles, and we don't have volume. What do we have? The unit tells you what you have. The unit says gram per dm cube, and we now know that grams per dm cube is the unit for mass concentration. What does this mean, grams per dm cube? Just like with this diagram here that I showed you, it's the same thing. Grams per dm cube, your numerator is the grams, and your denominator is the volume. So you have a specific amount of mass and a specific amount of volume. It says per dm cube, that means it's per 1 dm cube. So in 1 dm cube, you have 2.25 grams. So you have just figured out the volume. Even though you just get the unit of concentration, The concentration is mass over volume, so you do have the volume already, 1 dm cube. So to solve this question, all you need now is the moles, because you know the volume is 1 dm cube. It said that grams per dm cube. So if you have the mass and you want moles, how do you find moles? Remember now, mole is equal to mass over molar mass. Sodium chloride is the substance of interest here. The mass of sodium is 23 and it's 1 atom of sodium. And the mass of chlorine is 35.5 and it's 1 atom of chlorine as well. So that's 1 times 35.5. So that's 23 plus 35.5 and we get 58.5. And again, the unit is gram per mole. So 2.25 grams divided by 58 grams per mole. Zero point 0.039 So this is the moles. So we can come back up here now, 0.039 moles. And because we are divided by 1, the answer still is the same, but not the unit. 0.039, not moles, it is moles per dm cube. Because we are finding the molar concentration. So that's it. Let me check. Okay, let's look at what is a standard solution. So we can make solutions, as I said earlier, by dissolving a solute in a solvent. But if you know the concentration of the solution, meaning you know what mass you place in a specific volume, then you will know the concentration. If you know the concentration of your solution, that solution is referred to as a standard solution. That solution is referred to as a standard solution. So it's simply a solution whose concentration is accurately known. Accurately known or accurately determined. Alright? So let's say, in this scenario, let's say we want 250 cm cube of a 0.15 moles per dm cube sodium carbonate solution. What mass of sodium carbonate is required to make this solution? So what mass of sodium carbonate is required to make this solution? So remember, standard solution, a solution whose concentration is accurately known. So you know the mass of solute, you know the volume of solvent. The scenario here, you are asked to prepare now a 250 cm cube solution of sodium carbonate. They did not tell you the mass to use. They told you the molarity that is needed, which is 0.15 moles per dm cube, and they gave you the volume as well. So now, Remember, molar concentration is equal to mole over volume. So from here on, if you are given molar concentration and volume, and you want to find the number of moles, you will multiply. So mole is equal to molar concentration times volume. And again, volume must be in dm cube. So if molar concentration is mole over volume, simple cross multiplication, mole is equal to molar concentration times volume. Remember, your volume must be in dm cube. So 250 divided by 1000, you would get 0.250 dm cube. Why are we finding the number of moles? It asks us to find the mass. And we know that mass is equal to mole times molar mass. So we cannot find the mass if we don't know the number of moles. To get the number of moles, we multiply the molar concentration, which is 0.15 moles per dm cube, by the volume in dm cube, which is 0.25 dm cube. If the unit here was 250 cm cube, you could not cancel the cm cube could not cancel the dm cube. Right? The units must be appropriate. So dm cube cancels dm cube, you are left with moles. So now 0.15 times 0.25, and that is 0.0375. 0.0375 moles. So now that we have the moles, we can go ahead and calculate the mass. So 0.0375 moles. But we have to calculate the molar mass of sodium carbonate. Okay, let's just do it here. So sodium carbonate is Na2CO3. We have 2 atoms of sodium, so that's 2 times 23. We have 1 atom of carbon, so that's 1 times 12. And we have 3 atoms of oxygen, so that's 3 times 16. So that's 46 plus 12 plus 48. 106 grams per mole. So this times 106. Is equal to 3.975. So if you want to make 250 cm cube, if you want to make 250 cm cube of this solution, you will dissolve 3.975 gram in 250 cm cube of water. So that is how you will make this solution. I will do a video actually making up this solution. So if you are given the molar concentration and the volume and asked to prepare it, the first thing you have to do is calculate the mass of the solute that you will actually use. So you have to multiply your molar concentration by the volume, and you will get the number of moles. Because there is no instrument in the lab that measures mole, so you cannot go inside and weigh out 0.0375 moles. You have a scale that measures in gram, so you convert the moles to grams. So you can weigh 3.975 gram on your analytical balance inside the lab. And you have your volumetric flask, right, you will use to prepare your standard solution. So that's it. And this solution, we'll use it to do titrations and other stuff. So in our next video, we are going to do titration. So that's it for this section. We are going to continue in part 2 with titration. Remember to subscribe. If you have any question, you can ask. If you subscribe, press the notification bell, so once I upload a video, you will be notified.